We are in lesson 8-3. We're going to be solving our two-step equations now. We'll start off with the lunch problem.
The shaky bagel baker decides to just divide by 13 to decide how much to charge for each bagel. Does this method represent the per bagel price his crosstown rival charges for bagels 1 to 13? Explain your reasoning.
Be sure to try your hardest, but if you don't understand it, that's okay. It's just a lunch problem, so don't spend more than 5 minutes on it. When you're done explaining your reasoning, I will show you the answer. So, no, his method does not represent the price per bagel. And here's the work to explain why. You can pause the video and read through it so you can understand a little bit better. I am going to move on to the example problems. So in part 1, it wants us to write the modeled equation and then solve it. The equation that it wants us to do is this side equals this side. So how about you try and write out what you think the equation will be. So the equation is 3x plus 2 equals 11. Now it wants us to solve it. How we're going to solve it is by placing our zero pairs. So a zero pair is going to be something that cancels each other out. So if I have a 1 to make a zero pair, I combine it with a -1. Maybe. There we go. When I combine it, they go together, and that's showing me they cancel each other out. It's my zero pair. And then I'll add in another one and combine it. That's my second zero pair. Whatever I do to one side of the equation, I have to do to the other side. So there's my two negatives, and I can connect them with something that is similar. So -1 and 1, they're opposites, so they become my zero pairs. I'm now going to take my zero pairs and pull them down into these holding bins. As you can see, they go away. Whatever I do to one side, I have to do to the other side. They're going away because -1 and 1 cancel each other out. That means I am left with 3x and 9. So 3x equals 9. My last step is to separate them out so that I know what 1x equals. So I'm going to say that I want them into 3 different sections because I have 3 x's. And now I can just simply divide everything out. And as you can see, in each section over here, I have 1x. In each section over here, I have 3 1's. So I know that x is going to equal 3. That was a lot of work to go through, but what this allows us to do is it allows us to see it. A lot of times when we're working in class, we're just using numbers. So this is a great way to visualize what you are actually doing. So here's the got it problem, and I know that you can't look at the screen and solve it out using these, but if you want to draw this on a piece of paper, that could be really helpful. What I'm going to be asking is for you to solve this equation over here. So what is 6x minus 5 equals 19? And then again, using algebra tiles, you would just have to draw this out on a piece of paper since you can't move these on your screen. So what I can do is I can lock this equation, and I have 1, 2, 3, 4, 5 -1's on this side. And if I add 5 -1 or 5 positive ones, because it's the opposite, on this side, since I locked the equation beforehand, they also added it on this side, because what you do to one side of your equation sign, you have to do to the other. In that last example that I didn't lock my equation first, but this time I did. So the 5 positive ones I added automatically added over here as well. What I can do next is slide them over so that they match with their opposites, creating our 0 pairs. Over here I do not have any 0 pairs. There's no red negative ones. But over here there are, and what I can do is 0 pairs is remove them. They cancel each other out. -1 plus 1 is 0. What I can do now is separate my x's. I have 6 x's, but only 5 partitions. 1, 2, 3, 4, 5. So what I'm going to do is I'm not going to use this. And I'm just going to show you as if the partitions were there. So as you can see, I have them each separated. 1, 2, 3, 4, 5, 6. And I need to separate these into 6 groups as well. I'm dividing. So we'll do 2 at a time. One, 2, 3, 4, 5, 6. Those are my 6 groups, and I'm going to continue doing this grouping that I'm doing until I have none left. So 1, 2, 3, 4, 5, 6. They each have 3 so far. We're going to keep moving them along. Here we go. Here are my 6 groups on this side. They're separated into 6 groups on this side. So if you got the answer of x equals 4, you would have been correct. Here's our key concept.
Solving a two-step equation requires transforming the equation into a series of simpler equivalent equations until you isolate the variable on one side and a number on the other side.
So we first have to undo addition or subtractions. That's finding our 0 pairs.
Solve x divided by 3 plus 1 5/10 equals 2 75/100. Undo addition by subtracting 1 5/10 from each side. X divided by 3 equals 1 25/100.
Second step is undo multiplication or division.
Now solve the equation x divided by 3 equals 1 25/100. Undo division by multiplying each side by 3. X equals 3 75/100. Substituting 3 75/100 into the original equation, both sides of the equation are equal, so the answer is correct.
That is all that I'm going to have you do for this lesson. I know that some of you are still struggling with writing two-step equations. So what we will do when we see each other again is practice not only writing the two-step equations, but also solving them. If you have any questions, please let me know. I will be assigning the homework for you as well, but just know that we have not finished this lesson, so just try to get as far as possible through it as you can, and know that you will have more time to get it completed before I grade it and put it in Skyward. That's all I got for you.